everyone, welcome to the webinar. My name's Megan and I am training coordinator here at NeSI. Our webinar topic today is using Rmarkdown to create clear, reproducible analyses. Murray Cadzow is the presenter for today's webinar. He is a teaching fellow and postdoctoral fellow at the University of Otago and very active in helping researchers develop their coding and data management skills. So thanks, Murray, for being here today. Before we get into today's topic, I just have a few housekeeping items to cover. While Murray is presenting, we ask that you keep your audio on mute, but if at any point you have a question, please pop it into the Zoom chat. We're going to do our best to address those questions during Q&A breaks throughout the webinar. And there are a lot of attendees in today's webinar, so we apologize in advance if your question doesn't get covered during the webinar. You can always flick through an email if you need something else covered afterwards. So I'll just give everyone a chance to find the Zoom chat box if they haven't already. If you could navigate your way to the chat box and type in hello or test or something, just so I can make sure everyone can, find that Zoom chat. Great. See lots of hellos. Hello, everyone. And so if you want to share something verbally during one of the Q&A breaks that we're going to have throughout the webinar, please indicate that you want to say something out loud by typing hand. So /hand like that. Yep, you can do a little test now if you want. Raise your hand, and then I know that that you want to be unmuted and want to say something out loud. So lastly, the webinar recording and materials will be available on the NeSI website in the next few days. Those of you who registered for this webinar will get an email when that content has been uploaded. And if you do not want to appear in the recording, just make sure your video is turned off now by clicking off. There's a little icon on the bottom left of your Zoom screen, so make sure that your video is turned off. And let's see. So before I give things over to Murray, I'd like to do a quick poll. Let me find my poll thing in Zoom. And this is just to give us a sense of how familiar you guys are with Rmarkdown. So I'm going to launch this poll, and I will share the results with everyone in the group, so we're all friends. So don't be shy. Cool. And this will just help Murray to gauge and tailor today's material so that you get the most out of it. Okay, another second or two to give everyone a chance to vote. All right. And so the results, Murray, you see that? So we have about 50% haven't used Rmarkdown before, which is awesome. 40 or so sometimes, and a few experts who use it often. Great. So we have a bit of a mix. Cool. So with that poll information to kind of orient us, I'll now pass things over to Murray, who will get into the good stuff. Over to you, Murray.
Cool, thank you. I'll do the default. Can everyone hear me test while I find my share screen?
Yep, I can hear you, Murray.
Brilliant, right. Just a second while trying to find, there it is, right. Okay, so that's great that a lot of people are coming towards this with a either minimal usage or some usage, because that's sort of where I planned the content level of my webinar. I'm just going to move some windows around. Cool, and I can see chat. So hopefully, as I'm going along, feel free to chuck in a /hand, and I will attempt to at least see it. There is a point, probably about 15 minutes in or so, which I'll deliberately pause for some questions, because that's after sort of the bulk of the content. And there's probably about 30 to 40 minutes of sort of presentation stuff, and then after that, there's certainly going to be time for discussion and questions around what's been presented. Cool. I assume people can see my screen. Just one or cool. I see a nod from Megan. Great. So I've got actually I'll put the link for this in the chat window so that people can bring it up on their screens as well if they want it. And there is a GitHub repository with the examples in it if you'd like to follow along or go back to it at a later date. First up, there's a lot of resources that are available for Rmarkdown. They're at the top of this document. The best one is Rmarkdown, the Definitive Guide. It is the book written by UA and others who invented Rmarkdown, and it's very detailed. And then there's other RStudio resources and essentially stuff that I have borrowed from heavily in preparing for this webinar for you. Right, so what's the main motivation for using Rmarkdown? You might have had this sort of situation where in your work you've been given some code from other people predominantly, or you're making stuff from scratch. But often when we're talking about reproducibility, or at least in my experience, the code has generally been in existence, and I'm having to sort of wrangle it into my own thing, and I'm using stuff that other people have prepared. Sometimes it's not well documented. Sometimes like who knows where the particular file was that was used in creating these analyses. And sometimes it can be quite painful to try and recreate analyses that were done years ago. So where does Rmarkdown sort of help solve this problem? Well, Rmarkdown is a document in itself, but it's also it's a narrative-driven document which provides space for code as well as sort of the narrative around the code. So you're getting more than just straightforward comments about what code does, but you're getting more of that enriched experience about, you know, what was the thinking behind the code, how does this apply in the bigger context of things. So Rmarkdown provides a mechanism to create these compilable documents that then, in the context of an analysis, they contain both the code and the extra text around it. So you can write entire papers in Rmarkdown should you choose to. What are the benefits of using the system? Well, you've got access to Markdown formatted text areas. I will cover some of these in detail in a few minutes. We've got Markdown formatted text areas where we can use the language Markdown, which is a simplistic version of using sort of text to encode formatting of text. So think about like bolding or italicizing. There's a simplistic syntax for that. We then have another part of the document where we can have our code stored and run. So when we compile this document, both the text is compiled through and formatted nicely, and the code is run and embedded inside this document. One of the nice things about an Rmarkdown document is that it is compiled in a linear fashion. So therefore everything is sequential, and you don't get sort of jumping around, not understanding where things are coming from. The output of this document is self-contained. That's quite useful in that you can run an analysis, have all of the figures, all of the code, key tables, all of that is going to be embodied into maybe a single output. And then if you want to share that with other people, you can, and they get all of that stuff that was compiled out. I've covered slightly that narrative-driven code, or what's known as literate programming. So this is the more about human understandable text and the thoughts around the code rather than the code itself. And to me, one of the really big benefits of an Markdown document is that it is a plain text file. And where that becomes useful is if you've got things under version control, say Git, then you can manage the version differences in your Markdown file, and from that you can recreate just about any analysis that you've done. Some of the limitations of the Markdown format, being predominantly in R, parallelism is limited. And while Markdown does support many different languages, your language of choice may not be supported. And especially in terms of an HPC environment, checkpointing is somewhat limited. So if you've got a big analysis, it's slightly harder to checkpoint. And that's a really good point now to bring up, like, where in your workflow would you be thinking about running Markdown? For me, especially in an HPC environment, the majority of my sort of data preparation or say experiments would be controlled using various scripts that would generate data. That data I would then download, say, out of NeSI, and locally I would be developing an Markdown document sort of post the main data generation stuff, where the main purpose of an Markdown is to report on that analysis. So Markdown's strength to me is in generating sort of reports or analyses rather than doing the actual data generation in a computational fashion. Right, so what are the components of an Markdown document? This is where I will flick through to my RStudio interface. Okay, so an Markdown document is now what you're currently seeing. And, or at least can someone point out if they're not seeing that? Right, and so in an Markdown document, this example here that I've brought up is in fact the default document that when you're working in RStudio you would get. So if you went File, New File, Markdown in here, then you would get an option, and that's essentially how I've made this document here. And there's three main components of an Markdown document. The first is the YAML header, or the acronym is Yet Another Markup Language. That is denoted by these three dashes at the top and the three dashes at the bottom. That delimits where your YAML header is. It's found at the top of these documents. In there, we have these attributes that are defined. So we have a title, an author, a date, and an output. Following on from that, we have what's known as code chunks. They are denoted with a series of 3 backticks and some curly braces. So this is an example of a code chunk here. If it's not in the YAML header and it's not inside a code chunk, then that's essentially your Markdown area. So out here we have a level 2 header in Markdown, and here's some plain standard sort of text with some examples of formatting, say for bolding out here. And so with this document, we've specified that it's going to be an HTML document. If I wanted to compile, then I would click on the knit button, and that will compile through that document, and then the output that we get is, I'll switch over to there. So this is the compiled HTML version of that document. And you'll see, so here's our header, here's our author and date information, and there's our header. There's one of the things one of the nice defaults here is that, so we've got our text areas here that matches the text that was through in our document. We've got our bolding, and we've had one of the code chunks was creating a summary on this dummy data set called cars. We can see that the formatting of it is we have our code in our code chunk that generated the output, and then directly underneath we have the output from that command. So we're getting both our narrative in the form of our text, we're getting code to be able to do analyses, and we're getting the results of that code directly embedded in our document. And we can also include plots and other things like that, which I'll cover a few more of those details as we come across them. Right, so I mentioned that we have, so that was an HTML output. We have a multitude of other output formats, and one of the beauties of having this, developing your analysis in Rmarkdown, is that from this single document you can now create outputs in numerous different formats. So some of the base default ones say HTML, so that's great for interactive or animated types of documents. You got the traditional sort of PDF output. You can also output as a Word document. On the presentation side of things, you can create slides and that sort of thing for presentations. There's various different formats, so IO slides and Slidey, that traditional are an HTML format. Beamer is a PDF based format. If you're familiar with LaTeX, then Beamer slides are quite prolific. And we can also output as PowerPoint. And you can also, from the single compilation, you can make it output in all of the different formats specified. So this here is an example command of creating all of the outputs. So I can flick through to my example of a multi-format document and highlight how that differs from the default. So here, essentially what we're doing is we add onto our YAML. So before we had output : HTML document, and that gave us a single output. Now what we've defined here is numerous different outputs. So HTML document, PDF document, and a Word document. And inside there's additional options that can be given for outputs. In this case, the nesting sort of gives an idea on what components go with what particular outputs. So in this case, for an HTML document, TOC, which stands for Table of Contents, we're going to create one of those. There's an option called code folding. So by default, we can have the code that was used to generate the documents hidden, and there's a JavaScript button that'll display that for people. When we're creating a PDF document, we can create the table of contents. Because PDF doesn't is sort of a static type of document, the code folding doesn't apply. And for instance, here's the Word document default. And so if I run my command down here, so I need to change my input file to be, this one is multi-format, .rmd. So down in the code window, that was the code that I copied through. When I hit enter, get an error. Must be the output format. There we go. I'll update that on the documentation. And so over in, if I look at my examples thing here now, under multi-format, I have a docx. Might not be able to see too much of that highlighting, but I'll open it up so you can. Oops. And show the HTML. So that should be the HTML format there. We can have a look at the PDF, which involves a lot of screen share. There we go. So here's that same PDF, or the same Markdown, but now in a PDF format and with a table of contents at the top. Oops. Right, and so that's got, from simple addition to the YAML header, we've got multiple outputs to provide. Yeah. Right, some of the, so that's the YAML header. If we're talking about the code chunks, then there's multiple options that we can have with these. Somebody let me know if the highlighting is not working. Can you see that highlighted?
Yep, I can see that.
Okay, great. Okay, so in this sort of setup here, we can break down the code chunk. It's got a lot of extra features to it. So by default, a code chunk is denoted with 3 backticks, and then traditionally in Markdown, we'll be using R. So inside the curly braces, we specify the language that we're using. If we wanted to use bash, we would type bash there. I'll cover that in a bit later. But that's essentially the format that you use to declare a code chunk. But then we have extra options available to us. One of the really useful ones to do is to label it. So with a space after the R, we can give a label to this code chunk. This lets us, if we use one of the navigation panels, we can be able to jump straight to a code chunk that we know based on its label. We also have things like include equals false. So what happens if we have include equals false is that the code itself is run, but the output and the code chunk itself is not included in the document. So this is a good way to sort of declare the global options that we might want to set that aren't relevant to the actual content of the analysis. I see a question there, that was Control-Alt-I to generate a code chunk quickly. And then down here, we also have, so this other chunk here that was created in the summary, we don't have any additional options there. By default, the setting is to output both the code and the results of that code. But if you don't want to have the code showing, then you can set an echo equals false. If you wanted to have say if you wanted to demonstrate the code but not have it actually evaluate, then there's an eval equals false. So that there's sort of ways that you can toggle on and off what gets displayed and what doesn't get displayed. You could have just demonstration code there. An additional feature, so that we have code chunks, but we can also do inline R code and analyses. So if we come down here and type, say, the result of 2 plus 2 equals, I mean, a very reduced example here, but inline we can say R, so we can do a dip backtick and then R, and then we can, this puts us into an R code mode, and you'll notice possibly from the formatting here that the text color changes. If I knit that, then you'll notice that my maths was actually wrong, but down here, so I had 2 plus 2, but in the R code part itself, I wrote 2 plus 4, but it also demonstrates that it's independent of what you write in the text, but it does demonstrate that you can evaluate things in line. Okay. Let's bring that back. There we go. Sorry about the closing and openings of so many things. Right. So that sort of demonstrates that you can, where that becomes really useful, in fact, is if you have sort of data that you want to refer to later on, or whatever, you can load your data in, and maybe it has key variables that you want to talk about. You can have those evaluated inline, or if you've done prior calculations, you could have like the summary of your data included, and you could reference it. So you could have like calculate means and things like that on the fly. Right. As I mentioned, you can run different languages. One of the things that you can do, so there is a package called Reticulate, which enables you to pass data from Python through into R. But you can also use other languages. The one that I use often is SQL, and if you've previously defined a database connection in R, you can do direct SQL queries using that database, and you'd specify it as, so this is an example. I don't have a database ready to go, but you can specify your database connection here with something like DB connect, give the database parameters, specify your connection there, and then through in your SQL chunk, you can provide that same R connection, You can also set it up through the connections pane in RStudio, and there you could run your SQL query directly and get results back or pass them back through to R. So there's language things there. Some languages don't have a pass through to R, but still enable you to run commands in other languages. If that's useful. So one way to pass things between your different languages could be to write out files in between. Right. And then lastly, I'd just like to cover, before the question break, touch on the figures and tables. So here is a figures and tables contrived example. And essentially I just want to point out that there's a few different ways of creating tables with Markdown. The first way that I find the most useful and reproducible way is using one of the inbuilt data sort of converting functions that'll convert your data into a nice table. So in this case, I'm using the cable function from NetR, where I can give it a data set and say a caption, and when we compile that document, all of the table is going to be based on the data. You can, and so it's an automatically generated table. Because you have access to Markdown, you can also create tables manually in Markdown using the Markdown syntax. And so if I compile, I'll compile that through to demonstrate what those two look like. So here's our the code that generated it, and this is an automatic table below. So you can see the table caption is table caption, and this is a table of the empty cars data set with headings and stuff bolded. Below it is the example of the Markdown table. With the cable tables and there are other functions that will create nice tables from your data. You can do all kinds of other formatting. Some of it's available with the cable specification, but there is another package called Cable Extra that provides a whole lot of extra functionality. And yeah, depending on once you get into like complex formatting, that's where your output format does sort of dictate which changes are available to you. And then below here, we have that again, an example of including a plot. I think that's a good point, a good place to pause and answer some of these questions that I've seen coming through.
Yeah, so there's five questions from the chat, Murray.
Yep.
First one was, how does R Markdown compare to Jupyter Notebooks?
Yes, so I myself don't have a lot of experience with Jupyter Notebooks. They are very similar. So with Jupyter Notebooks, you can have text and code and run them. One of the things that one of the reasons why I prefer Markdown to a Jupyter Notebook is the forced linearity of compilation. That sort of helps me in my thinking. But they're very comparable. I suppose one of the key differences is that a Jupyter Notebook is probably more of an interactive environment for people. But yeah, ultimately they're very similar in my understanding.
And then a follow-up question, can you elaborate on what the parallelism is and why R Markdown is not suited to it?
Oh, yes, yep. So I mean, especially in like a HPC environment, you might be running well, you might want like to run programs that have multi-cores or run, say, 3 or 4 different models at the same time. By default, R it's all right, but generally it's a single threaded or single operation, serial task oriented language. And so if you want to compile things in parallel, it's a little bit difficult. Can be done, but it's if you're after creating or doing modeling with lots of threads, then you're probably looking at doing it outside of the Markdown document itself, and maybe like loading those results in later.
Cool. And you mentioned writing a paper in Rmarkdown. Are there collaborative editing features and options for citing papers?
Yeah, so the way that this would be done is probably through some sort of version control system. So using, say, Git as the mechanism to collaborate would probably be the way to do it. Or you can do things like in the cloud. So RStudio has a cloud environment where you could all log in and do sort of like a Google Doc type thing. Don't know if I'd recommend that way of collaboration. But yes, there is a mechanism for citing papers. So in the YAML header, there is a way to declare a bibliography, and then you give it a bibtec file, and it'll, when you cite through the Markdown syntax, it'll embed the citations and create that for you. I see another one here. Can you have buttons and interactive plots? Yes. So you can embed, this is predominantly with the HTML format, where you can have interactivity fairly easily. You can embed shiny objects. You can embed, you can put in probably JavaScript applets. You can, there's definitely libraries within R that enable you to have interactive plots. You can put in like Google Map applets and stuff like that. So yeah, the HTML format is very versatile. You wouldn't be able to have the interactive stuff with some of the other formats though.
What's the difference between R Notebook and R Markdown documents?
Yeah, so they're very similar, and in fact, I think behind the scenes they use the same system. I think that the R Markdown is kind of like the beefed up version of a notebook, say. So a notebook gives you like some, again, I'm not super familiar with the notebooks, but I think it's sort of the options are available to you. So the R Markdown is kind of like the supercharged version of a notebook.
And then LaTeX, I don't know how to say that correctly.
Yeah, LaTeX.
Okay.
Yes, you can use LaTeX straight in the document. I don't know LaTeX myself, but you can. So for my thesis, I had to do a combination of. So I wrote my thesis using Bookdown, which is an extension of Markdown, and in that, it was bringing in like a LaTeX template, and I could put in LaTeX commands to control things like that. So, yep, you can also, for HTML outputs, you can write CSS chunks to control formatting and stuff like that.
And then the last question was, can the Markdown file that you're working on be made available to everyone?
Yes, it is available, and I mean, other than that, this inline one, all the documents as they started off were at the link at the top of their HackMD. Thank you, Laura, for posting the direct link. Yeah, they're all available. I can add my changes that I've just done to that. Cool. So with that, it's probably worth moving on for the final sort of 5-minute discussion about how you can use Markdown to like further improve upon your scripts and your documents to improve the reproducibility of what you're doing. Let me switch to that window. Where's it gone? Let's try that one. Nope, that's not it. Yeah. Okay, that should be the HackMD. Right. So, I mean, in my experience, I use Markdown quite a lot, and often it's for these one-off analyses type things. But one of the things that we can start thinking about is the maintainability of these documents. And this is where this thing that I came across at our studio conference earlier in the year of this Markdown driven development. So in the first iteration of things, essentially getting it working is good enough, right? But then as especially if this is going to be a report or something that other people are going to depend on, we can start to think about improving and reorganizing how the document is laid out to improve how it can be maintained and the thinking behind things. So often the design of, as you're creating the initial document, everything happens sort of as you need it in that flow. So you're kind of like do a little bit of computation, have some data visualization, then you move on to the next thing, compute, change it around and format, visualize, that sort of thing. That's great for a first effort, but especially if this is going to be passed on to somebody else, or if it's going to be developed upon, then it can make good sense to start trying to group like things together. So say in the first example here is rearranging chunks, so putting all of your computational steps all together sort of towards the start of the document, so then as people come to maintain this document, they know where to look within it rather than say the computational steps being spread throughout. Then you can go further and you can modularize things down. And I mean, the ultimate end of this particular workflow could be the creation of an R package where all of your scripts and all of your data and things are nicely contained in the structure that is an R package. Some of the things that you need to think about, so the main stages of this reorganization sort of thing is removing your troublesome elements. So you don't want to have like passwords and hard-coded paths, say, in your document. There's ways of loading in, say, configuration files or using relative references to files to make this more of a portable document. Rearrange your chunks. You want to reduce down the duplication of your functions. So if you've got functions that are essentially doing exactly the same thing that you've defined throughout your document, perhaps they can become slightly more generic and defined once. That makes it easier to maintain that rather than going through and finding all of the spots that you need to change something if you need to change how that function operates. Ultimately, you can start migrating from an R Markdown to what's in an R project. So what I'm talking here is obviously very R-centric, but it can also be used in other languages. And then finally, you can convert your R project to a package. Now this way, each project that you're working on is going to have a different stopping point, and it's one of those sort of, it's an art to work out whether it's worth going that extra step. And there's nothing to say you can't go back and improve upon things later. Right. Then there's things that are beyond Markdown. So Markdown is sort of like a single sort of document level thing. What happens if you want to create multiple documents or different sort of mediums? So Blogdown is a extension of Markdown that creates a blog website using Markdown. Bookdown is a package that enables you to create books out of Markdown, and that provides the ability to do like cross-referencing of figures and tables, as well as like a giant bibliography sort of thing. Packagedown is an Markdown flavor that is designed for documentation of R packages. And when you're starting to think about this reproducibility thing and where, say, this reproducible document might fit inside an entire workflow and the levels of reproducibility in a computational sense. So there's things like, if I sent my R Markdown file to somebody else, they might not have the same versions of R packages installed. So that's where environments might come into a play. You could wrap your entire analysis up inside of a Docker or a Singularity image to get around some of the packaged versions. And ultimately, if you're thinking about doing things like your entire analysis workflow, then things like UPS, webinar on the common workflow language, and defining sort of like this ultimate wrapper around like how do I transport this analysis around. So you're defining all of the packages and software prerequisites to this analysis and having it all able to be transported to other machines. So there's lots of different layers to this reproducible issue. So Markdown is generally, in my experience, like sort of an easy entry point. So we're worried about, can this exact code or something be followed along? But then there are the extra levels of, how do I make sure that all my results don't change based on package versions or other software things. At the very bottom of this document are a few extra R packages that are quite useful. So that's the end of what I have there, and I can see there's some more questions. Scroll up a little bit.
Yeah,
Right.
The first one was, what are your first 3 routine steps when creating a new R Markdown script? Can you recommend any tutorials?
I don't know if I have 3 routine steps. My routines, I suppose, would be creating a project. So I try and modularize whatever I'm working on. So if it's a particular analysis, I try and format or create a directory on my computer that where I'm going to stick my analysis document, my data, my outputs, all of that. And I have a very consistent structure. And I suppose for that sort of tutorial, I highly recommend the data carpentry, either ecology or social sciences workshop about project setup. Creating the R Markdown document, I generally start off with that default one and delete everything that I don't need. Right.
The next one was, we'll be able to source a customized function from another Markdown code chunk, or do you have to save the customized function to an R script first?
Yes, yes, you can. In fact, in one of my examples, I have an example of that. So you can create a code chunk beforehand and then reference it later. And the way to do that, let's quickly switch to there. What was it in? It was in fact, so in the Fig and Tab example, I have an example here of, you can define your code chunk, say, and not have it displayed. And then you can in fact call upon that code chunk later. Otherwise, if you've got, in R, you could define the function well ahead of where you use it and use it there, or you can also source in other R so if you've got an R script that has, say, your functions in it, you can source that in. Ultimately, you could make your own R package that has those functions in it and call that as a library call at the start of your documentation. Depends where you want to go and the amount of effort you want to put in.
Cool. There's another question. Can you expand on what an R project is?
Yes. Yes, I can.
And if there's any follow-up questions, Murray, feel free to chime in, unmute yourself.
Cool. So an R project is, so if I went File, New Project, save those changes. It gives me the option to create a new project. Essentially what this is it'll create either a directory on my computer or it'll download one, say, out of GitHub. But essentially it's saying, where do I want R to now focus as being the center of my analysis. So if I went new directory, I then get to choose the type of project I want. Normally I'll go new project, but if you're developing like an R package or a blog down site or a book down thing, choosing one of those gives you essentially the skeleton structure for those particular project types. But yeah, essentially what it is it's a directory, and inside of it, so down here in my files thing, this webinar in fact is a project, and essentially at the bulk of it, the crux of it is RStudio will create this file called a .rproj, and that tells RStudio sort of like what the defaults are for that project. But yeah, and from there you can develop it further. It's essentially a default structure. And there are some other packages that, so the here package will use the project file as sort of like the anchor for your relative referencing. So if you use the here function, it'll always start off at the root of the project directory, and then you can do relative references to files based on that directory structure. Right.
And then can you use referencing softwares like Mendeley or Paperpile in Rmarkdown?
Not that I know of. So there's a few RStudio add-ins that enable you to connect to your bibliography file. So generally you're dealing with a bibtextfile file, which you can create out of Mendeley, and I assume Paperpile as well. So when I was writing, I used Mendeley, and I would export my collection as a bibtex file, and then I could reference out of that. So it uses a very similar reference style to LaTeX, but there was one or two packages that I could use for searching through the BibTeX file if I needed to. Right, and then the next one I see is, someone's tried to write a bioinformatic pipeline in Rmarkdown using an R notebook and had issues with crashing and not loading libraries. Okay, then some code. I would say that, so this particular question looks like it's trying to install libraries if they're not installed and going in and getting the script to do it. I would probably avoid doing that. So I would probably set my document up with the assumption that the libraries are installed. And so the issue would become if you're passing them off to somebody else, they might not have them installed. One of the things, yeah, so I would have my library calls all at the top, say at the very first function, and right, so I would generally leave it as just the library call, and then R will give you an error if you don't have that library installed. Also, if you're passing this off to somebody else with RStudio, it'll generally tell you what libraries are or are not installed and prompt you to install them. So that's a way around that. Otherwise, maybe have an install script, or I generally would avoid any sort of installation stuff inside an Rmarkdown file itself.
Okay. If you don't mind, I think that's all the questions actually, so we did get through all of them. I'll quickly wrap up with a little wrap-up slide, and then I'll send you guys on your way. So if you wouldn't mind, stop sharing your screen,
Yep.
Murray, and I'll pop up a little slide. Okay. Cool. So that's it for the webinar today, guys. Before you go, I'd like to point out that there's a bunch more content in the resources section of that hackpad that Murray was presenting from today. If you need the link, I'll ask if someone can pop that into the chat one more time, and you guys can bookmark it so that you can go and review that content later if you like. Also remember that the best way to get NeSI specific support is by emailing support@nesi.org.nz at any time with your questions. Keep an eye out for the webinar recording and slides. Those will be posted to the NeSI website in the next few days. And thank you once again to Murray for taking the time out today to deliver this content. And thank you guys for coming. I'll see you again at another webinar soon. Thank you.